And I think I got everything rolling right now. Okay. Oh well. Okay, so to get again, just to gosh, off to a shaky start. Here we go. Yesterday was the discrete random variables, so we talked about specific outcomes. Today is going to be continuous. So we have some examples of continuous that we've actually already talked about continuous before, way back in chapter one, actually 1B. So our example of a continuous one is going to be if I had a normal distribution. Or if we had a uniform distribution. So those are the two examples that we'll hit this morning. The probability distribution is described by a density curve. So we're going to go back and hit density curves. So again, the skill here is not going to be anything new. The heights of young women closely follow a normal distribution with a mean of 64. So again, this is a nice one because it's actually got all of our stuff labeled. We need to start getting the habit. If it doesn't, we just need to start in the habit of that. So we have a mean of 64 and a standard deviation of 2.7. Define y as the height of a randomly chosen young woman. Y is a continuous random variable whose probability distribution is, and again, making sure that we understand notation. If we see that notation, just a reminder that um, the n here, it tells you it's normal. The 64 is going to be the mean, and the 2.7 is the standard deviation, which we knew already, but just in case they just give us that notation straight up. What is the probability that a randomly chosen young woman has a height between 68 and 70 inches? So again, this is where we're going to write a probability statement. We want the probability that the young woman is between 68 inches and remember, we have to remember we're going to use the right variable now, so we have to use that variable y, and that's less than, where's my other, my right-hand boundary is 70. Okay, so if we're going to go back and review things that we did from a normal distribution, we would have to convert each of those into a z-score. So that means we'd have to go with 68 minus 64 divided by 2.7. And unfortunately, I don't have that in my notes to do it that way. But this is just a general review of this. So we got 4 divided by 2.7. So we get a 1.48. And then we would have to look that up in the table. We'd have to do for the other boundary, 70 minus 64 divided by 2.7. So that means that we're 6 above. And that gives me a 2.22. And then we had to remember that we had to convert each into a percentile first. So the other part that we're missing on this is we missed our picture. So it's then going back to all those things that we had to do beforehand. So in the middle of this, we have a 64. I'm talking about between 68 and 70. So we're going to have all of those. Okay. That's this area is what we're trying to find. Okay. So different ways we can do this. So just to refresh, 1.48 and 2.22. Let's see if I can't remember those. So we're going to go out to our formula sheet. It's been a while since we've been through this one, but again, at 1.48. So here is the 1.4. And now we're going to go over to the 8 column, and that gives me a 9306. I can't remember all those numbers in my head, so I'm going to have to go back to it. Okay. If we go out and do the 2.22, so here again is the 2.2, here again is the 22 part of it, and then we get 9868. So that means that we're going to find the difference between those two percentages, 0.9868 minus 0.9306, and that gave us a 0.0562. Now, remember, there was another way to do that. If you're going to your calculator, and we'll just refresh all the ways, we could have done a normal CDF on our calculator. The left-hand boundary was 68. The right-hand boundary was 70. It had a mean of, what had a mean of? 64 with a standard deviation of 2.7. Okay. Now, remember when we were doing this, I was always making you go back and write down that this is the mean and this is, oops, that's not the mean. This is the left-hand boundary, this is the right-hand boundary, this is the mean, and this is the standard deviation. I'd always go back and do that. However, because that is defined within my problem, that would have been an unnecessary step, but it's always good just to cover your bases, so you do that. So just a reminder on your calculator how we get there. We go out to our calculator, if I can find my calculator. We're going back into, remember that's in my distribution, if I can find distribution. That was a normal CDF, so that's option number 2. My lower boundary, if I clear that, was 68 to 70. Is that what I did? I don't know. It's going to be what I got to do. We'll hope it matches up. Because now I can't remember my mean is 64. And golly, my standard deviation. Can anybody help me out? What is it? Is it 2.7?
Yeah.
All right. So again, that was our shortcut, 0.0561. So again, it's your choice on how you get there as far as whether you're using a calculator or whether you're doing it by hand. But that's our options. Okay, 0.0562. Suppose the weight crumbs left on the floor of a restaurant is uniformly distributed. See graph. Find the probability that during a given 1 hour period between 3 and 4.5 crumbs are left on the restaurant floor. So looks like this is my I don't know. It looks like we're going from 2 to 6. Okay, oddly enough. Find the probability that between a given 1 hour period between 3 and 4.5. So we'll choose a different color so we can definitely differentiate here. Um, there is 3. Here is 4.5. We're trying to find out what's the likelihood. What's that probability? So remember, when we're talking about a probability, the probability is really the area underneath a density curve. Okay. So it didn't define a variable for me. So this is a probability that the crumbs, we'll call them crumbs, are between 3 and 4.5. And just a note on equality statements, I did it happen on the other one too. We don't have to on these probability statements. We don't have to put the less than or equal to sign. Okay, it's strictly just less than. It's automatic. It's just an inferred thing that it's equal to when we talk about a continuous curve. And where was I going with that? All right, so now we had to find. So remember, the area underneath my curve is uno. So I had to figure out what the height of my curve is. We are 4 units wide. Since we're going from 2 over to 6, it's 4 units. So that means for that area to be 1, it's going to have a height of 1/4. So when I take 4 times 1/4, we get an area of 1. Okay, so that's how that's going to work. To find that area, we're going to take the width. The width of my area is 1.5. The height of it is 0.25. And so really it's just the area of that shaded rectangle in red. And it looks like that's 0.375. Okay, so that was again different styles of problems. We're doing continuous variables. It's always the area under a curve. So our examples were, we started out with our bell-shaped curve, our normal curve, that single symmetric single-peaked curve. And we went to a uniform, and I believe example number 5 is another uniform one. The manager of a large department store with 3 floors reports that the time a customer on the second floor must wait for an elevator has a uniform distribution ranging from 0 to 4 minutes. Find the probability a randomly selected customer waits less than 1.5 after pushing the button to the second floor elevator. All right, so unfortunately, this is the same exact problem as the one above it. I was wondering why I had that scratched out in my notes. All right, so we're going to change this problem. So otherwise, it's the same exact calculation, which is stupid. So we're going to change this to a 2. No, we can't die on me. All right, so we said that we're going to have a uniform distribution anywhere from 0 to 2. So that means since this has a width of 2, it has to have a height of 1/2 in order for the area of my rectangle to be 1. We are trying to find out less than 1.5. So here is our 1.5, and we're trying to find the area of the shaded region. So again, the probability or the area of the shaded region that, and again, we're not given a variable. We could call this X. We could call it W for wait time. We'll just call it W. And actually, I goofed up just in the fact that I introduced that variable C up here. C is going to be equal crumbs. And just like here, we need to say W equals wait time. So if we ever introduce a variable, we have to define it. So that wait time is less than 1.5. So that means it's going to have a width of 1.5 and a height of 0.5. And when we multiply those together, we get a 0.75. Okay. I actually did want to go on and do one problem into the next section, just because if that way you could get started on it. Because I think if I just do the one problem, we can do this without issue. I'm looking at the time, thinking I burned up way more time than I thought I was going to burn up. Um, am I still going to do this? I think I would rather do this. Is this going to help me in the long run? Oh, I have to make a decision here. What decision am I going to make here? I'm afraid if I go in and lecture this is going to be a little bit more than a 10-minute explanation, because I was expecting the other part to only last 5 or 10 minutes. And between my Zoom issues that we didn't make it, um, I think I'm still going to try to hit it. Looking real fast, we have the mean and variance of random variables. Okay, so now we're going to have that probability distribution. It's here we have a nice little chart. Refer to the buckle example on the previous page. So this is that buckle example, and we want to find out, well, what's the mean and standard deviation of the number of items sold by that particular person at the buckle. Okay, so we have a formula to do this. It is written, the formulas that you're given are written out here. If we flash back real fast, nope, not going to go there. If we go back here to our formula sheet and scroll to the very top, we see we have a section in the probability distribution. So this is in section 2. We have already talked about, we have seen these on the last test. Those are the two formulas that we use. However, now what we have is we have a section for probability distribution. And we can see in the probability distribution section, we have a mean and we have a standard deviation. Okay, and we have formulas for that. So the formulas then are all going to be given to us. We don't have to remember any of these formulas. We just have to remember where to find them and how to use them. So that actually works out nice. Okay, so we're going to quickly talk about how we're going to use the formula here. So we're going to go back to my notes key. So we have to understand that the different parts of this. Okay, so this is going to be my mean. This stands for expected value. This is going to be our sigma, which means the sum. And what we have to do is realize what we have here. We have x, which is going to be the outcome, and p, which is going to be the probability. So we can see that if we want to find the mean of this distribution, the mean of x, it is going to be the product of 0 times 0.2 plus 1 times 0.35 plus 2 times 0.15 plus 3 times 0.12 plus 4 times 0.1 plus 5 times 0.05 plus 6 times 0.03. So we can see that that is going to be a one heck of it's just typing all that in straight into my calculator. Outcome, we're taking, again, we're basically, it's all these pairs. And my pen died again. It's those products. That's what that whole entire series is, just those products added together. Okay, that's how we're going to find the mean. And in this case, the mean turns out to be 1.84. So now we're going to go over here to the standard deviation of x. Now, if I look over here, and this is going to be different, I forgot, I didn't realize this was different now. I knew they updated the formula sheet, but I didn't catch this update to it. This is given, and I can't see me pointing. This equation here is actually a variance equation because it's my standard deviation squared. If you go and you look at the formula sheet is actually giving us the standard deviation. Okay, so we have to remember, to get to the standard deviation, we're just going to square root both sides. Okay, and if we go and look at the formula sheet real fast, it is going to show us again, it's got standard deviation, and it's got the square root sign in there. Okay, so just note that little difference there. I didn't catch that update in the formula sheet, so we're flying a little blind here. But this one gets even uglier. Okay, so because now what we're going to do is we're going to take the difference, but again, standard deviation is your average distance from the middle. So I need to find out how far is 0 from the middle. So we're going to find that by taking and subtracting off the mean. We want that mean to be positive, so now we're going to square that, and then we take it times its probability. So this becomes really ugly notation, because my mean is 1.84. We're going to square that. We're going to take its times its likelihood of 0.2. So the next term is going to be 1 minus 1.84. We're going to square that, take it times its probability of 35. Okay, now, so again, this is really ugly because we're going to do that for each term. Now, the nice part is, we're going to write this out, actually, we're going to write this out once, and then I'll show you the shortcut method for this. It's a little nicer. I'm losing track. I'm trying to talk and write at the same time, and for some reason today, I don't have that in my skill set. And can you imagine typing all this into your calculator? That is going to be ugly, and I wouldn't expect you to type that in your calculator. We just need to know that this is going to turn out to be 1.604. All right, now I wanted to hit this real fast. We only got 5 minutes left, so again, I probably ran. I didn't have time for this, but I wanted to. You can actually get started on a lot of your homework if we just go ahead and do this. Now, I didn't interpret this at all. What am I going to do? Okay, so now that we have those down there, now I'm going to interpret those. The typical deviation. Nope, nope, we're not doing, that's not a deviation. The typical articles of clothing purchased at the buckle from this salesman is 1.84 garments on average. And we're going to need that average in there. The typical deviation from the mean of 1.84 garments is 1.604 garments on average. Okay. Wow, I'm sorry. I rushed you on that. I made a poor choice. I didn't have a with a class coming in here at in 30, and you guys had to be somewhere in 30. So in 2 minutes here. So let me real fast jump over and show you the other part to this, the part that made it easy, because this is actually a calculator problem. Because what happens now is we can go stat and we can go one and we can drop those outcomes into a calculator. So if you look at list one is all my outcomes from the buckle. If you look at list two is the probability of all those outcomes in the buckle. So now what happens if I go stat and I go over to calculate and I choose a one variable statistic where L1 is my list. So the outcomes is my list. Now we're going to get in this frequency thing. So now we're going to put L2 as a frequency. So the probability is the frequency. And so the list is going to be my outcomes. The frequency list is going to be the probabilities. And we're going to hit calculate. And I'm getting that mean of 1.84 and that standard deviation of 1.604, which is exactly what we had over here when we did that. Okay, so that's a shortcut to that. Okay, so I'm going to stop my screen sharing because we have officially ran out of time. That's not what I wanted to do. I want to stop my scan. So I'm sorry. I probably made a bad decision on rolling through that, but I was thinking maybe you could get a head start on some of that homework going past that. So I thought I'd get that extra example in there. So um, if you got a question, you feel free to ask. Other than that, I hope you all have a great Thanksgiving break, and I will see you in 6 days. So you're coming to the party a little early. This is
Good
advisory.
morning.
Yeah, good morning. This is advisory
I
time.
can't. I think you're muted.
What? Oh, I'm muted? That's weird. No, I can hear myself through my iPad, so I think I'm working okay.
I can't hear you, Mr. Dottie. I don't know if you're talking to me.
Yeah, I am. I'm talking to you. Yes, I am. But I can hear myself. So that's what I don't understand here. Whoops, I need to stop recording.